Hi, everyone. My name is Tracy Schloemer, and I've been an Arnold Beckman Postdoctoral Fellow at Stanford University from 2022 to 2025. And I'm here today to share a little bit about my research, as well as the broader impacts that this fellowship has really provided for me. And so I'm just going to minimize my face so you can see the science and not me. So, light-driven materials really have the opportunity to change the world from how we make chemicals, how we can understand and control our brains, how we can deliver drugs, and how we can manufacture things with 3D printing. But light-driven materials are only powerful when you can get the color of light you need where it is needed, or else you can't do any of these processes without the right color of light in the right spot. And today I'm going to talk to you a little bit about 3D printing and manufacturing and how we can deliver the light we need where we need it. And so imagine that I want to print this robot. Going to sit on my desk for the next 30 years. It's going to keep me company. And I'm going to print with light because it's going to give me better resolution compared to other methods. And how this will work is there is a liquid goop that can be changed into a solid when it's exposed to blue or UV light. So we have a resin vat, we have a light source, and I can turn this liquid into a solid by projecting two-dimensional images over time to build up this 3D robot shape. But you'll notice here I didn't just print the robot, I also printed a lot of support structures. These support structures allow me to make the robot, but they must be clipped away, leaving blemishes on the surface. And then also about half of this print is going straight into the trash. And so let's flip that script. Let's reduce that waste and make sure that my part doesn't have unwanted blemishes on the surface. So let's expand this resin vat. Let's, instead of making 2D slices at the printing 2D slices at the bottom, let's just trace a little dot to convert my liquid into a solid to trace out this robot. And then I can eliminate the support structures. And maybe I can even reuse some of the excess liquid that didn't make the robot and use that later. But this really begs the question of how can I generate a blue dot and control it on the inside? What color of light, or how could I do that? Or what color of light do I need? What materials do I need to do that? And that's really my work, where we can do this process. We can convert actually red light into blue light. And so I'm showing a video here where I've focused a red laser beam, and it is tracing out the shape of a benchmark standard. It's a little tugboat you'll see in a moment. And there's just a little dot of blue in the middle that's really tricky to see in this video. But I promise only that blue is going to be able to turn that liquid into a solid and create this tugboat. And I just want to show you what it looks like when I wash away the extra liquid. Here is Benchy sitting in front of a little Lego scientist that comes with me from lab to lab, as well as a dime. And ultimately, I have these numbers about the powers, but really what they represent is I can print this boat by transforming red light into blue light. And I can do this with powers really similar or smaller than that from a red laser pointer, and in times that are much faster than other ways that you could make this boat using a commercially available volumetric 3D printing system. So how do we do this? How can I convert this red light into blue light to make that benchy and to do that really fun science? And that's with nanocapsules, little nano vehicles where I can deliver up conversion materials that can convert red into blue light. And so inside of this nanocapsule, if we think of it like a little nano ravioli, except this ravioli is 1,000 times thinner than a hair on your head, I've stuffed some molecules on the inside. So I have mushrooms inside of my ravioli. And then on the surface of my ravioli, or maybe the sauce on the outside, I can put different sauces so that I can have different well, in this analogy, different flavors, but ultimately the surface of my ravioli allows me to put it in the 3D printing resin so it doesn't fall apart. And this really inspired my postdoctoral fellowship and to really broaden um, the power of these nanocapsules, these nano raviolis, to really better understand how can we make this process more efficient and get more photons out. Maybe I don't always want to use red light. Maybe I want to use different colors in or get different colors out. And then finally, what are the different sauces that I can put this ravioli in so that this ravioli doesn't fall apart and can really deploy these up conversion materials and change the color of light for different 3D printing contexts or even beyond. And so a few scientific impacts was have many of them have been in collaboration with other folks who have been Arnold Beckman postdocs, which has been really incredible to work with such wonderful people. And so I worked with Dr. Sam Sanders on this proof of principle for the volumetric 3D printing. Got to work with Dr. Mike Burrows and Professor Danielle Mai towards more sustainable 3D printing, where you can maybe use one color of light to write or make a print and a different color to erase it or to undo that print and regenerate your liquid goop, and using up conversion. And then beyond the applications, it's really important that each of my nanocapsules or my nano ravioli have really predictable performance. And so I got to collaborate with Dr. Connor Harper at UC Berkeley to really understand how those nanocapsules form for increased predictability. Beyond the science that I got to conduct, I also got to share science in other ways with people in my community. So I got to facilitate a few solar cell workshops that were specifically funded by my fellowship and would not have been possible without it, as well as supply Arduino kits to teachers in Oakland, California, right across the bay from me. So as I wrap up this video, Dr. Arnold Beckman has had these rules for success that are posted on his website. And I just want to emphasize number 5 for you as I wrap up. Don't be afraid of making mistakes. If you're not making mistakes, you're probably not doing very much. Everything I showed you today was made possible by making a lot of mistakes to really develop understanding to make these things work. And so I'm very, very grateful for the opportunity to make mistakes, and for the Arnold and Mabel Beckman Foundation that gave me the opportunity to do this. Thank you so much.